Located in the heart of Segamat, the Maybank ATM provides convenient banking service for the local community. It allows customers to perform essential transactions such as cash withdrawal, balance inquiries, fund transfer, and bill payment. With its strategic location, the Maybank ATM in Segamat is an essential financial hub for residents and visitors alike. Maybank branch that have been chosen for our study is located at Jalan Ganuang, Segamat. It operates 16 hours per day and number of servers is 4. There are 3 objectives of our study. The first one is to study and analyze the flow of customers using the Maybank ATM in Segamat. Next is to evaluate the efficiency of the ATM system by calculating average waiting time, service time, and queue length. And lastly, to learn about the characteristic of the place which is at ATM Maybank Segamat.
Our first characteristic is the size of the calling population. In this system, the population is finite as the number of users is limited to specific customers within the area such as residents in Segamat. Next, let's discuss arrival patterns. Arrivals are random but tend to peak during lunch hours, weekends, and salary disbursement periods like monthly paydays. Customers' behavior plays a crucial role in this system. Some customers may choose not to join the queue if it looks too long, which we call bulking. Others may leave the queue if the waiting time exceeds their tolerance level, known as reneging. Regarding the line's length, it is potentially infinite, as there are no strict limits on the number of people who can wait in line. The system operates on a first-come, first-served basis, meaning customers are served in the order they arrive. Let's look at the service channels. The system employs a multi-server, multi-line, single-phase approach to ensure efficient customer service.
These are the data that we get for our assignment. For counter 1, we got 18 customers from 11 AM to 12 PM. For counter 2, we got 12 customers from 11 AM to 12 PM. Okay, for counter 3, we got 15 customers from 11 AM to 12 PM. And lastly, for counter 4, we got 21 customers from 11 AM to 12 PM. The table shows data of the queuing time and the service time for each customer at 4 counter ATM Maybank in 1 hour from 11 AM until 12 PM. Okay, for counter 1, the total number of customers are 18 and the total service time are 46. For counter 2, the total number of customers are 12 and the total service time are 42. For counter 3, the total number of customers are 15 and the total service time are 43. And for counter 4, the total number of customers are 21 and the total service time are 39. Lastly, from the data, we get the total number of customers is 66 while the total service time is 170.
Now, let's take a look at the queuing model. The total service time recorded is 170 minutes. When we convert this into hours by dividing by 60, it gives us approximately 2.83 hours. This value helps us understand how long the system takes to serve all customers. Next, we have the average arrival time, which is represented by the symbol lambda. It is calculated by dividing the total number of customers by the total time in hours. In this case, we have 66 customers within 1 hour, meaning that the arrival rate is 66 customers per hour. Now, moving on the average service rate, which is represented by the symbol mu. We calculate this by dividing the number of customers by the total service time in hours. When we divide 66 customers by 2.83 hours, we get an average service rate of 23.4 customers per hour. We approximate the number and we get the lambda is equal to 24 customers per hour. Let's now look at the result of our queuing modern analysis. First, we have the utilization factor, which represents the probability that the service facility is being used. It is calculated by using the formula lambda divided by S times with mu. In our case, the arrival rate lambda is 66, the number of servers is 4, and the service rate mu is 24. Substitute this value, we get the 66 divided by 4 times with 24, which is equal to 0.6875. This means that the service facility is being utilized about 68.75% of the time. Next, we have the probability of zero customer in the system, also known as the percent idle time, represented by P0. This is calculated using the given formula which taken into account the number of servers, the arrival rate, and the service rate. After substitute the value and solving, we find that P0 equal to 0.0537. This is indicate there are 5.37%, hence that there are no customer in the system at any given time. Understanding this value allow us to find other value by using other formula that help us calculate every part in equation. Let's analyze other result of our queuing system performance. Firstly, we have the average number of customer in the queue, represented by LQ. The formula used to calculate this is P multiplied by lambda over mu raised to the power of S multiplied by P0. Substitute the given value, we get the 0.6875 times 66 over 24 to the power of 4 multiplied by 0.0537 divided by 4 factorial and 1 minus P squared. This result is an average of 0.901 customer in the queue. Next, we calculate the total number of customer or units in the system, represented by L. This includes both the customer in the queue and those currently being served. Using the formula L equals to LQ plus lambda over mu, we substitute the value and get 0.901 plus 66 divided by 24, which is equal 3.651 customer in the system. Moving on, we determine the average time a customer spent in the system, denoted by W. This includes the time spent in the queue and the time spent being served. Using the formula W equal L over lambda, we divide 3.651 by 66, resulting in average time of 0.06 hours. Lastly, we have WQ, which is represent the average time a customer spent waiting in the queue. Using the formula LQ over lambda, we divide 0.901 by 66, which gives us approximately 0.01365 hours spent waiting in the queue. This calculation helps us understand the customer flow and identify the potential area.
To check our calculation, we can use QM for Windows. So the first one is waiting line result. The result is same like the calculation before, which average server utilization is 0.69. Average number of the queue in the queue LQ is 0.9. Average number in the system L is 3.65. Average time in the queue WQ is 0.01. Average time in the system is 0.06. Next, we can check the sensitivity to the number of servers. So we can saw that the QM for Windows show all the average server utilization, average number in the queue LQ, average number in the system L, average time in the queue WQ, and average time in the system W for each server. And lastly is the table of probabilities. It's the number of customer from 0, 1, 2 until 24. Lastly is the conclusion. For comment on the number of server provided and the customer waiting time. First question, is the number of server provided adequate? Yes, this is true since the rate of customer service exceeds the rate of customer arrival. And next question, is the customer are happy with the waiting time? And the answer is yes, they will be satisfied because they would not have to wait for a long time to be served. For 3.1.2, describe what you have learned from doing the project is first one, with new average service rate is greater than lambda average arrival time, it shows that the server provided are enough to serve the customer at fast rate. However, if the average arrival time lambda is greater than mu, the average service rate, it shows that the server cannot handle too many customers, and this will increase the waiting time because of poor of server. In conclusion, we learn how to describe the basic queuing system configuration